So number one, you're talking about an escalator, so that's like the moving stairs, right? So it's going to be going up. So if you're thinking about a right triangle, that's the hypotenuse. Your vertical side is 15. Your angle with the ground, so that would be down here, is 30 degrees. We're looking for this, so just think SOHCAHTOA. Sine is opposite over hypotenuse, so the sine of 30 is the opposite side, 15, over the hypotenuse, x. Sine of 30 degrees, we know from our hand trick, is 1/2. So 1/2 equals 15 over 2. Cross multiply, and x is 30 feet. Is that okay? Number 2, first you have to think about quadrants. Tangent and cotangent do the same thing. They're positive in 1 and 3, so it'd be negative in 2 and 4. So we'll have an answer in each. And you can also fill out a unit circle if that helps. If cotangent is 1, that means tangent is 1, and that happens at 45 degrees. So 45 degrees in quadrant 2, 180 minus 45 is 135. In quadrant 4, 360 minus 45 is 350. Number 3, we have right triangle ABC, and C is 90 degrees, A is 43, and side C, so that would be across from angle C, is 80 centimeters. I want side B, so the side across from angle B. So if we think SOHCAHTOA from my 43, this is adjacent and hypotenuse, so that would be the cosine. 43 degrees equals B over 80. We don't know the cosine of 43, so we'll use our calculator. Make sure you are in degree mode. And then you just type in 80 cosine of 43. Now when you do that, you get 58.5083. The directions said to give significant digits. When you look back in the problem, 43 is 2 significant digits, but 80 is just 1. Because there isn't a decimal, that 0 doesn't count. So if you round this to a single significant digit, that would take it all the way up to 60 centimeters. So if you had 58 or 59, that was just a significant digit difference. Problem 4, we're trying to find angle A. And what we know is we have 2 right triangles here. So on the right, we know this angle is 30 degrees and this side is 10. On the left, all we know is a single side, and we're trying to find angle A. So we need to first find the side that they share. So if I want to look here, because it's a right triangle, we can do SOHCAHTOA. Sine of 30 degrees is opposite over hypotenuse. Sine of 30 1/2 equals x over 10. 1/2 times 10 is 5, and I didn't give you any units. So now that we have that, we can look over here. From this, that's opposite and hypotenuse, so that's still sine. If you're looking for an angle, that's when we did the inverse on our calculator. So if we do the second sine, 5 over 6, that gives you 56.44. Direction said round to the nearest degree, so 56 degrees. So far, first 5, any issues with those? Number 5, I think we did have a little bit of trouble with that one. And I think this was actually one from a test. So you have a person standing on top of a sand pile. And it's 13 foot high. So I know this is 13, and we would assume that height would be perpendicular with the ground. So we do have 2 right triangles here. He locates 2 rocks on the ground at the base of the sand pile. They are on opposite sides, so we have a rock over here and a rock over here. The angles of depression Remember, an angle of elevation starts at a horizontal line and goes up. An angle of depression starts at a horizontal line and goes down. So from that horizontal line, I'm giving you these angles are 19 degrees and 25 degrees. I want to know how far apart the rocks are. So what we're going to do is find each of them separately. Let's say this is A, this is B, and then we'll have to add them together. So we need an angle. Hey.
CTA.
Oh, thank you.
You're welcome. Have a good day.
Thanks, you too. So when we're looking here, we know we need an angle in the triangle. And you can get a couple different ways. Alternate interior angles, so this would be 19 degrees down here, or you could do 90 minus 19 and get the 71 up here. Either way, I think most people got the 71 from when I was answering questions yesterday. If you did that, A is my opposite, 13 is my adjacent, so that is tangent. So the tangent of 71 degrees equals A over 13. So if you multiply that 13 over, so then for this one, 90 minus 25 is 65. So from that you could do the tangent of 65 equals B over 13. Multiply over your 13. And B is 27.8786. Add those together, so A plus B, and you get approximately 66 feet. I think I rounded mine to significant digits, but we were told to at the very end, just make sure you don't round until the end, don't do it in the middle. Is that okay? Number 6, we have a 76-foot high flagpole, so we would assume that makes a right angle with ground. Shadows are on the ground. Angle of elevation is a horizontal up, so we are looking for this angle right here. So tangent, opposite over adjacent. So you have to do tangent inverse on the calculator. So if you type that in, second tangent, significant digits would be 3 digits, so 53.1 degrees. Number 7. So we know sine is negative 0.3060. To find an angle, you have to do sine inverse. I've told you don't put in the negatives, just do the positive, and this will give us our reference angle. So if I do sine inverse, so second sine 0.3060, I get 17.8183. But it says we need to do quadrant 3. So how do you place something in quadrant 3? So if you add 180, you get 197.81. So number 8 is similar, except I gave you cotangent, and we don't have a cotangent inverse button. So remember, if we know cotangent, tangent is the reciprocal. So to get your reference angle, you will do tangent inverse, so second tangent, 1 over the positive 0.7394. And that gives us 53.5208. Oh, did I? It was 0.7395, wasn't it? I wrote that down wrong. I I'll probably change my last couple decimals. So 53.5171. Then it tells us we are in quadrant 2. So how do you put an angle in quadrant 2? So if I do 180 minus the 53, we get 126.4829 degrees. All right, so that's kind of SOHCAHTOA problems or beginning inverse problems. The next ones are all those application problems. So things you have to remember, you have to know what your variables stand for. So capital A is area, S is your arc length, that's the distance on the outside of the circle. R is your radius. V is linear velocity. Theta is your angle, but what does it have to be measured in? Always. Radians. And omega is angular velocity, which also has to be in radians. So if either of those is in degrees or revolutions, we have to convert them. Best option on these is to kind of make a list of the variables you have and what you want. So number 9 says find the radian measure. So the measure is theta. The arc length is 6, so that's S. And the radius is 2. So then if I look at my formula sheet, S equals R theta. So 6 equals 2 theta, divide by 2, and theta is 3 radians. Remember, you don't have to write a unit for radians. You could write the word radians if you chose to, but it's not required. Anytime we don't have a unit, we're assuming radians. So 10 says find the linear velocity. So linear velocity is V of a point moving with uniform circular motion if the point on the outside of the circle covers a distance of 45 miles. Distance on the outside is S in 3 hours. So hours would be our time. So then we could just look at our formulas. V equals S over T. So 45 divided by 3 is 15. If you're doing units, 45 was in miles per, 3 was in hours, so 15 miles per hour. Number 11 says our angular velocity, so that's omega, is 10 radians per second. The radius is 3 feet. We want the distance traveled on the outside of the circle, so we're looking for S in 4 minutes. So T is 4 minutes. Now here's the big problem. If you look, 10 is radians per second. My time is in minutes. We need those to match. So how could I get that? What would be my best option? Change that 4 minutes into seconds, so just times 60. So that's 240 seconds. You could also change this one to minutes if you chose, just divide by 60. So we're going to have to use a couple formulas here. Our formulas, we have V equals S over T. That involves S, but I don't have V. Or S equals R theta, but I don't have theta. So we're going to have to use 2 formulas. If I want to do S equals R theta, we need a formula with theta first. So we could do omega equals theta over T. So omega equals 10 equals theta over 240 because we're in seconds. You multiply that over, theta is 2,400. So S is 3 times theta, so 3 times 2,400. We get 7,200 feet. Number 12. Our our sprinkler rotates through 90 degrees. That's our angle, but we can't use degrees, so 90 degrees is what in radians? Projects water out 53 feet. That is giving us our radius. We want the area, so we're looking for capital A. So our formula, A equals 1/2 r squared theta. 1/2 times 53 squared times pi over 2. Okay, so several different ways you might answer this. If you kept it in fraction form, it's like 2,809 pi over 4. If you did a decimal but not multiply out the pi, 702.25 pi. Or if you did multiply out your pi, 2,206.18. So any of those are fine. Area is always square. So that's square feet. Definitely don't need all three of those answers, but any one of them is sufficient. And last question. A wheel with a radius of 5 feet, so we know r, rotates 13 revolutions per minute. That is, there's a couple ways to interpret it. One is to think of that as an omega because it's a rate. But omega always has to be in radians. We have to change our revolutions into radians. So 1 revolution is all the way around the circle, which is 2 pi radians. So if you just multiply, that's 26 pi radians per minute. You might have done it differently. You might have said your angle is 26 pi and your time is 1 minute. That would also get you there. We are looking for linear velocity, so we want v. So v equals r omega. 5 times 26 pi gives us 130 pi. Units, if you have extra units, those go away. Linear velocity, it's a rate, so it's something per something. Has to be a linear distance like inches, feet, miles. If we look, our radius was in feet, so we'll travel 130 pi feet, and our time was in